Hello everyone and welcome to this session. What can Azure do for your batch data analytics workloads? So first of all, I like to say that you should explore the past community. That is the community that brought you this session and this conference as well. Explore your local groups or virtual groups which are abundant this time of the epidemic, basically. Other than that, if you missed the past summit 2019, you can get the recordings online. The new past summit 2020 is being organized, so take a look at that as well. Also, thank you to our global sponsors and supporters, as well as our local sponsors and supporters, because without them, we wouldn't be having these kind of conferences. So, first of all, a little bit about myself. Who am I? I'm a senior database developer at Span from Croatia. My background is in maths, and I have a passion for data management and analytics. I work mainly with databases, data migration tools, a bit of data reporting, analytics, etc. So, what is this session going to be about? It's going to be about what Azure can offer for the whole data architecture of your solution. Since this is going to be an overview session about how you can take individual services and pieces to make an efficient data architecture, first I'm going to cover the most common data services in Azure. I'm going to focus on the native ones. Most of them, probably most of you know, but we're going to cover them nonetheless because they are building bricks for a data architecture in Azure. And then after that, I'm going to talk about a few examples of Azure data architectures for batch data analysis workloads. Basically, this session is just an overview because when you start with cloud data architectures, you can be overwhelmed with the amount of services offered, especially since Microsoft is pretty open to other services other than their native ones. This is what we'll be touching on. Most of these services you probably heard about either before online by yourselves or in other sessions in this conference. Okay, so first of all, when we talk about data architectures, we need to have some data stores. Some of the most common ones are, for example, Azure SQL Database. If you're coming from an on-premise SQL Server instance, what it is a general purpose relational database, which is provided as a managed service. There are many deployment models. Some of them are single elastic pool managed instance. Basically, a single deployment model is like having one database in an on-premise SQL Server instance. Elastic pool is when you have multiple single databases, but you provision basically the scalability you provision across all of them. So you don't put an upper limit on computation and storage per instance, but per few instances at once. And the managed instance is a full-fledged instance like the one that you might have on premise. There are multiple purchasing models. The old one basically is DTU. It's also still very used because it's the lowest tiers of it are much cheaper than vCore. Then the new, basically, let's say the new one, it's a few years old already, but the one that is recommended if you're starting from scratch is vCore model, where you choose how many vCores you want your instance to have, and RAM, and you know exactly how much RAM you're going to get along with those vCores. And there's also serverless, where you can scale storage and compute independently, and you can even pause compute if it's needed. Purchasing models for DTU are basic, standard, and premium. Basically, they are about scaling the computation and also the storage. For example, for premium, you always get SSD disks. And vCore-based architectural models can be general purpose, business critical, and hyperscale. The distinction is also about basically about scaling. General purpose is for some general uses. Business critical ensures much higher SLA numbers for your availability of your instance, and hyperscale is for the biggest instances that you might need. I think it's up to 100 terabyte of storage and a lot of computation. What this service offers you, as opposed to, for example, an on-premise SQL Server instance and on-premise databases, are, for example, automatic performance monitoring and tuning. There's also a lot of auditing available if you turn it on, etc. So this is the most common service for data storage and querying, of course, if you're moving from an on-premise solution to the cloud one. Another one that is sort of let's say the same. If you want to change only a few items in your architecture, and if you don't want to change a lot, then you might consider moving to SQL Server simply in an Azure VM. Basically, it would be the same as you having it on premise, but you're using Azure as your infrastructure layer. Still, in this case, you would have to take care of your SQL Server instance. You'd have to patch it regularly, etc. So another interesting one in Azure space is Cosmos DB. I'm going to touch on it just a little bit. It is a globally distributed multi-model database service. What it means is that you can have multiple models of your data available in Cosmos DB, which is most of them are so-called NoSQL or not only SQL models, which are key value, document, graph, and column family. Cosmos DB enables you to scale elastically and independently throughput and storage basically across any number of geo regions worldwide, and it does all of it under the hood. You just need to choose, for example, about when we talk about geoscaling, you just have to choose which regions you want your solution to be available in, and it will scale automatically. There are some considerations when choosing on how to sync those, especially if you scale through many regions for writes, then you have to choose basically if two writes for same item come at different times in different Azure regions, how is Cosmos DB going to decide which one should be taken for all of the other instances when they sync in between? The way that Cosmos DB works and that it can deliver you all of these multi-model services is because under the hood, it actually uses so-called atom record sequence, which is the way that it stores data. And then when you use one of the APIs available, then it can very efficiently translate and project the data onto the model that you are using. So the available models are SQL, which is also called core model. There's a MongoDB API, Cassandra API, Azure Table API, Gremlin, which is for graph data, and etcd, which is in preview now, and it's associated with Kubernetes. Some of these are also very similar to other offerings in Azure, for example, Azure Table API. The difference is that basically what they do in Cosmos DB is offer you a premium version of the Azure Table service. So the way the data is structured within Cosmos DB is that you have one database. Inside it, you may have multiple containers, which depending on the model are either tables, collections, or graphs. And then inside of them, you have items, which also depending on model are documents, rows, or nodes or slash edges, if they are graphs. Cosmos DB, as opposed to many other NoSQL solutions, offers you 5 consistency levels, whereas many other solutions basically give you strong what is like strong and eventual in Cosmos DB. So you have 5. I'm not going to go through them now because they require more analysis, but you can look them up online what they mean. Basically, strong is the strongest one, and it says if you make a write to a single region, then it is going to be, let's say, committed only when it is accepted by all the nodes in your solution. And the eventual is the complete opposite. Basically, if the node that you are writing to says the write succeeded, then it's going to say colloquial that they all succeeded even though they still didn't, because it's going to asynchronously make the writes to other regions. Next up is also a very common one when you move to Azure, which is Azure Blob Storage. There are also other types of storage in Azure, but this is the most common one. It serves basically for all the types of files that you have, and you can drop them up on Azure Blob Storage. That's why it's very often used in big data solutions. And even if you don't have a large quantity of data, but you have various types of data, then you also often use Blob Storage. It's a Microsoft's object storage solution for the cloud. It's optimized for storing a large amount of unstructured data. Basically, when you deploy it, when you provision it and deploy it, when you connect to it, you make so-called containers, and inside those containers you can put whatever type of objects and files you want, from media files to documents to whatever you want. There are a few access tiers: hot, cool, and archive. Choosing them depends on how quickly you can access your data, but also how expensive it is to keep it up there. Replication is there are various types of replication. The cost of Azure Blob Storage also depends on which type you choose. Basically, there's local redundant storage, zone redundant storage, geo redundant storage, and geo-zone redundant storage. The differences are on how many copies of data Microsoft makes. So local redundant storage is basically Microsoft within the same physical region and within the same server farm. Basically, it makes a few copies of your data, which is how it makes it resilient. Zone redundant storage is when within the same zone but different server farms, it makes copies of your data. So if one physical location gets hit for whatever reason, your data is still safe and replicated elsewhere. The geo redundant is the same, but for multiple regions. And geo-zone redundant storage is when Microsoft replicates your data across regions, but also within regions across different physical locations. Azure Data Lake is another offering which is connected to NoSQL and very big data. It's highly scalable, parallel, and optimized for big data analytics. Basically, it's like why it's called a lake, and is because you basically just put everything in it, and it's optimized for a lot of data ingress, but also you can then use it to efficiently make queries on it. using data lake analytics. It is low latency and high throughput. Basically, it can be considered like an unlimited blob store because blob store has some limitations on how much data you can put there. And it has, as opposed to blob storage, which only has virtual folders, it has a real hierarchical file system like you can find on your computer. But the question is, what happened to it? Because when you search for data lake on Azure, it should be there as a Gen 2, but there's no such service offered. So the question is, what happened to it? Is it discontinued or what? So I'm going to talk more about that later. Now we move to data pipeline orchestration. I'm not going to go into details here because you could talk for hours about even the elementary things in Azure Data Factory. Basically, Azure Data Factory V2 or Gen 2 is the one that's currently in use, even though you can still provision the Gen 1. It is a code-free ETL or ELT data ingestion as a service. Basically, you can, when you provision it, you can define so-called linked services, which are, for example, SQL Server, your Hadoop cluster, your Blob Storage, any kind of storage on Azure or on-premise. If you're using on-premise services, then what you have to do is install a gateway within your domain. It allows you to create data-driven workflows or so-called pipelines that can ingest data from disparate data sources. What Data Factory is like an SSIS for the ones that are familiar with it, but in the cloud. So you make linked services, as I already said. Then based on them, you define the data sets, which if it's an SQL Server, an Azure SQL database, or something similar, then you define either selects or whatever can be a source for your data. You also define where your targets, basically, so your sinks, which can also be a database or a file or whatever. Then you define activities, basically what you're going to do with the data, if you're going to copy it, maybe execute store procedures on SQL servers or on Azure SQL databases, or whatever you're going to, whatever the activity is, you can make custom activities as well. You can write C# code or any kind of code, or run any script that you want to. And basically, then you make pipelines for it, which is a cluster of different activities, and you run them as one. You can also, what is not mentioned here, you can also trigger them to run at the moment that you want to as a schedule, or they can be event-based. So, for example, you can make a pipeline that triggers when a file enters, for example, a blob store. Okay, next on, there is something interesting that Microsoft did with Data Factory. They recognized the need that you might already have a solution on premise in SSIS, and they made it available to you to be able to basically just lift those packages to Data Factory, and they can still work. So what you need to do is provision Azure Data Factory, which is going to serve like a wrapper around your SSIS integration runtime, and then you can lift your databases online. That was just a brief overview of data orchestration in Azure. Next, I'm going to move on to batch analytics. Batch analytics can be done on, for example, Azure SQL Data Warehouse on a Gen 2. What that is a cloud-based enterprise data warehouse which uses so-called massively parallel processing to quickly run complex queries across even petabytes of data. Behind the scenes, it Well, actually, if you connect to it, so for example, using your management studio, it looks very similar to your on-premise SQL Server, but the difference is that behind the scenes it acts very differently. You still use relational tables, but they are behind the scenes in columnar storage, and also they are distributed across, well, depending on how you scale it, but across possibly 60 compute nodes. So when you run a query, then what happens is the SQL Data Warehouse automatically translates your query into a query that is going to be run efficiently across 60, possibly 60 compute, up to 60 compute nodes, and over 60 different parts of storage. So well, it depends how your storage is distributed, depends on so-called indexes that are specific to SQL Data Warehouse. They are something that you need to get used to when you make your solution, but it can also be trial and error. So there are 3 different types of indexes that you can do for a table. The first one is hash index. Basically, it will hash based on your primary key, and it will distribute the data pretty much the same across all nodes. So they are going to contain all of those 60 different storage parts will contain approximately the same amount of your data. Sorry, no, that's for round robin. So that's round robin. It's randomized. Then you can define hash based on some column. What you need to do is know the data and how it's distributed, so that you can do it very efficiently. And usually, if you do it like that, it's more efficient than round robin, which is randomized. And then you also have replicate, which says basically replicate the whole table across all of the file parts. But what it also means is that your storage requirements will increase potentially exponentially, because the same data will be replicated 60 times. Importing big data into SQL Data Warehouse can be done using so-called polybase very efficiently, using simple TSQL queries, and the performance is really staggering. I did some demos on I think hundreds of millions of rows from flat files, from CSV files, and it was done like an hour or so on a very low performance setup. So I think it was even the lowest that you can go with SQL Data Warehouse. Okay, so now here the question is, what's happening if you want to provision an SQL Data Warehouse and type it in Azure? You're not going to get that service. So is it discontinued, or what happened? Well, basically, no. What Microsoft did is made a rebranding of this offering. It's called Synapse Analytics, and I thought the Synapse is this. I'm not sure how it's connected to data, but here we are. It's called Synapse Analytics, and it's what they say, limitless analytics service that brings together enterprise data warehousing and big data analytics. What they did here is recognize a requirement from various types of roles that in modern data community arose, which are, for example, data analyst, database developer, data scientist, etc. And they wanted to make a central hub for all of them to be able to analyze the data, make ELT or ETL pipelines, analyze it, whether it comes from relational sources or NoSQL. And this is what they did. They call it Azure SQL Data Warehouse Evolved, because Gen 1 of Synapse Analytics It's basically just the rebranding of Gen 2 of Azure SQL Data Warehouse, and the new step, so Gen 2, would be what I already mentioned, Azure Synapse Analytics Studio, in which a data engineer can build an entire end-to-end data pipeline in one place. So it combines, like you can see in the picture, it combines data warehouse and data lake workloads into one offering. Okay, other than that, we also have Azure Data Lake Analytics. It's an on-demand analytics job service. It has dynamic scaling because you pay only for the processing power that you used. You write USQL language queries, which are very familiar SQL, but with the expressive power of C# when it comes to data transformation. And it works with Azure Data Lake Store for the highest performance and throughput, but it can also select data from storage blobs, SQL database, and SQL Data Warehouse. Since SQL Data Warehouse is, well, not discontinued, but rebranded, and Azure Data Lake Storage is also now basically a part of Synapse Analytics. The question now is, will it work with Azure Synapse Analytics in the future? I looked it up, and I guess we'll simply have to see. For now, we are sure that it works with Gen 1 of Azure Data Lake Storage, which you can still provision. But it's not as efficient as Gen 2 is. Okay, so another offering is Databreaks, which is an Apache Spark-based analytics platform that is optimized for Microsoft Azure Cloud Services. Basically, what this means is that it's integrated with Azure services because Databricks is a separate firm which made a partnership with Azure. You can basically behind it are fully managed Spark clusters which you provision. You also get an interactive workspace for exploration and visualization through notebooks. Because you are using notebooks, it's a very good workspace for collaboration and documenting progress, and you can write various languages in there, R, Python, Scala, or SQL. You can visualize data in a few clicks using tools like Matplotlib, ggplot, or D3, and you have an out-of-the-box integration with Power BI from the Power BI side. So you have a connector, native connector for Databricks. Okay. Another interesting one is probably familiar to people who are familiar with SQL Server Analysis Services, which is an on-premise solution for analysis of data. On-premise, it has two different models. It can be multidimensional or tabular. Tabular came to us when we got columnar storage. Since this is something that is more and more efficient as hardware progresses, it's the only model that is offered in Azure Analysis Service, so you can only provision tabular models. It's a fully managed platform as a service that provides enterprise-grade data models in the cloud. So you don't have to worry about infrastructure or anything, you just provision it as a service. It has advanced modeling features to combine data from multiple sources, define metrics, and secure your data in a single tabular semantic data model. And basically that's it. It works pretty much similar to the on-premise analysis services, but only for tabular model. Now we get to playing with these services and setting up various data architectures for batch analytics workloads. Now we have building bricks to make, let's say, our house that will be efficient. And sometimes what you get to, especially when you start in this in this field and you want to make a complete architecture, and not one or two services are enough for your solution. When you have more of them, this is what you get. You make errors, you make mistakes, but that's completely fine. Mistakes are something that you, especially with something like Azure, which offers you many services, even for a single need that you might have. This is something that you learn from. So when you make mistakes, you learn from them, and next time you know better. I'm going to go through a few examples now, which are the most common ones. So, for example, especially if you move from an on-premise solution, what often you want to do is store the data somewhere in the cloud and then be able to analyze it. You can do the analysis, of course, you can do the analysis with Azure SQL Database if your data is not too big. But also you can use, for example, something like this. This is an example of extract, load, and transform with Synapse Analytics. You can have data source on premises or even in the cloud. You do an ingestion of data in, for example, storage blob, and then some of the data using Polybase gets inserted into Azure Synapse, or how it was called before, Azure SQL Data Warehouse, and then you can do analysis on it. You can do the analysis within Azure Synapse, because especially if you have lots of aggregations, because it is very, very efficient with those kind of queries. When I did some tests with the same data already mentioned, that was very efficiently ingressed into Synapse. I basically couldn't make a query. Now we're talking about queries with aggregations, with relatively simple aggregations, maybe some filtering, but I couldn't make a query that took over, I don't know, 10 seconds over like 100 million rows. So it can be really fast and efficient. But if what you need is drilling down on various attributes, and you need a tabular model of analysis service, then that's something that you can also use. So analysis service, as I already mentioned, can connect to Azure Synapse or Storage Blob, and when you make the model, you can, for example, visualize it in something like Power BI, which can be integrated for security purposes to Azure Active Directory. So yeah, this note down here says Synapse Analytics powered by Polybase, even without analysis services, would work here. And all you need for performant Azure data solution. So if your data is not as complex, you can probably be fine even with Azure SQL database, because as I said when mentioning it, it also has various range of different models. For example, if you don't need a lot of storage and you need a lot of computing, you can probably get by even with serverless offering of Azure SQL database. As your needs get bigger and bigger, then you can move to Azure Synapse, for example. The next step would be analysis services if needed, etc. Okay, so another example here is very similar to the one to the previous one, but it has an added data factory for easy external data integration. So Azure Data Factory is a go-to service when you need to take data from various sources. It really has a ton of connectors, and from Microsoft services and different types of data stores to any other, basically what you can think of. I won't even dare to put a list here because it's being updated all the time, so you can check it out online. You can just type data factory, data sources, and you'll get a bunch of them, a whole list. That's a different thing when talking about Azure data offerings that I'm going to mention here. All of them are getting changed like all the time. Sometimes if you're not keeping up and a month or two passes, a big deal could have happened. So it's something when you're starting to, even if you know the basics of how you want your architecture to work, every time you start a new project or you want to consider moving to the cloud, you should investigate on what the current situation with all of the services is. So Data Factory is awesome when you want to integrate various sources. This is what's being used here. For example, if you have multiple external data sources and you have even on-premises network, which to access, as I said, you only need a gateway within your domain. You can ingest the data to Blob Storage or even directly to Azure Synapse to store it and analyze it. You can move it if needed to analysis services and then visualize it with whatever method you want to. For example, Power BI visualization, which in and of itself can also be connected to a lot of sources directly if you don't need if you don't need a lot of transformation or aggregation of data. So if your data is already plain and simply very close to what you need to visualize, you can freely even use just Power BI to connect to anything in Azure, for example, or even on your on-premise network. All you have to do is install the gateway. Here's an example of data processing with Databricks. So now we're moving a bit more to the NoSQL side. So if you, for example, have logs, files, and medias which are unstructured data, and you also have some structured data and you want to combine them together, what you can do is deploy Azure Data Factory to make a migration or copy all of the data from logs, files, and media, whatever the source may be, load those flat files to, for example, a data lake on a schedule. So because we're talking about batch processing here, not talking about real-time processing. Then you can, on the other side, with structured data, you can either pull it into an Azure SQL DB or Synapse Analytics, formerly Azure SQL Data Warehouse. You can then use, for example, Azure Data Factory, or even use the Databricks itself to connect to both Azure Storage or Data Lake Store and SQL DB or Synapse Analytics or whatever you had to pull the data in the Databricks using DBFS or simply selecting from the relational data stores. And then when you, if needed for serving purposes, you can use Synapse Analytics before even making reports or using it in an application, but you can also use it directly from Databricks, those data into an application or reports. What Databricks already touched briefly on it, but what is cool is if you want to use it. Well, I said it's a tool that you can use R language in it, Python language. So it's also a very useful tool for data scientists. So basically, if you have any predictions or any predictive data or any analysis of history data, but that you want to do from a data scientist perspective, you can do it in Azure Databricks and then use those insights in your application or reports. Okay, any data at any scale can be used. Basically the limit to what you can do is, well, the amount of money you have. So some of these services can be quite costly. That's why you have to tune your data architecture to be as efficient from the cost side as well as from your business requirement side. So what you can here's an example of data that's at any scale, because before we had some structured data that where this transactional layer storage was dependent on how much data you have. Here is something more along, it's still batch processing, but it's more along the sides of being near real time, for example, because you have a large quantity of data coming in your system. So you could have logs, files, and media, which is unstructured data, and also structured data. You can ingest all of them using Azure Data Factory with, for example, scheduled triggers. You can pull just the delta of the data into your Azure Data Lake storage, for example. Then using Polybase, you can pull the data directly into Synapse Analytics, and if needed, model it using analysis services. On the other hand, you can even pull the data in Azure Cosmos DB to be globally distributed and available, much more efficient than it would have been in Databricks for your web applications. For example, if you have a retail store that's globally distributed and you have customers coming from all around the world, then this is something that you could definitely use. And then on the other side, you could have reporting on top of those models, which in that scenario where you have you would have a lot of data, so maybe analysis services would really serve you well when analyzing data from different perspectives. Okay, so in general, advanced batch analytics patterns in Azure are like this. So you from a source perspective on the left, you could have sensors, IoT, general unstructured data, like also logs, files, media, but also structured data. You need to, more often than not, in today's modern architectures, more often than not, you need to combine the data. So you could use Data Factory for cloud orchestration, or list your SSIS packages up in the cloud. You might have some model training, which I, other than Databricks, didn't touch on much, but some solutions are using ML server on, for example, on a VM. You could have a deployed Azure ML Studio. You could use in database SQL Server ML. You could use some VMs on which you drive your custom model training as a data science VMs. You could also use Azure's AI offerings. On the other hand, you need to store the data somewhere before it gets to data processing. So you could use various things like Azure Storage, Cosmos DB, which offers you data at great scale from various models, Azure SQL DB, as well as Synapse Analytics, which can also be used in this part on the right for serving storage and data processing. So for data processing, you can use Hadoop HD Insight offering in Azure, or Data Lake Analytics, or Databricks, or, as I said, Synapse Analytics itself. And then, depending on your requirements, you can then use it in your application or applications. And in reporting, basically, what I want to show here is that some of these services can fulfill different needs depending on what your business requirements are, and maybe even depending on the costs that you can handle. So, for example, a great showcase of this is Synapse Analytics, which is the newest addition, I think the newest addition to data architecture in Azure, which can serve almost all of these purposes. Basically, other maybe than model training, it can serve, I think, all of these, depending on your requirements. If you have some, I would say, third-party data that you need, third-party vendor data that you need to incorporate, then maybe you would have to use custom solutions. But even then, you could leverage Azure Data Factory to get the data inside, for example, Synapse, and then you can do everything else in Synapse. But if you have a lot of prediction going on, then you definitely need a separate service that will fulfill that need. Okay. So in conclusion, I started off talking about different pieces that can go together well or not so well. In conclusion, with regards to having Lego being different pieces and different services and offerings in Azure, this is also a possible result that you can do with the Legos. So basically, what we want to do is get to something like this. You want, okay, maybe when you start off with your data architecture, it's very rough around the edges, but as time goes by, you simply have to work on it, get the costs down without sacrificing the performance, and even improve the performance by possibly moving to different services if needed and if required. And I mean, for a single solution, even if you get to a point where you can say, okay, now my data architecture is as good as it gets, keep in mind that things change even within that same service, or you simply get a new business requirement that you have to do and you have to start working on it all over. You can either improve it or add additional services to your solution. Okay, I think I finished a bit early. Thank you. Still, thank you everyone for listening. I guess you'll simply have more time for lunch break. I ask you kindly to go to speakerscore.com/s2g2 and rate this session. And if you have any questions, feel free to ask them now, either by muting yourself and simply asking them, or just write them down and I can try to answer them. Thank you all for coming. Bye.